So this paper is equal pay for similar work, which is joint with Diego Gentile, who was a grad student at Brown, is now at Amazon, and Fuhito Kojima, who many of you may know. Um, and I thought I'd start with a little background about myself. One of my earliest memories was my dad taking me to daycare when I was a kid. And he would sometimes tell the other children in the daycare that I was Robin, Robin being Bobby's twin brother. Um, the issue is I don't have a twin brother. I don't have a brother at all. And this was 30 years ago, and I'm still talking about it. So clearly it had some impact. Um, uh, so this will hopefully become relevant coming up in a few slides. So here is maybe a more standard opening slide. And this is comparing the median earnings of full-time workers in the US. And what we can see is men make more money. This is probably not so surprising. And I'm not trying to give reasons as to why this is, but um, this is a fact that many people have documented. It's there in Europe as well, although slightly smaller amounts. And the sense is, well, firms are playing a role in this. Clearly, firms are the ones who sign the paycheck, and they have some ability to determine wages. And we may dislike the way that firms set wages, right? And these may violate our societal fairness goals. And a response to this has been a policy known as equal pay for equal work. This is an extremely catchy slogan. And if you look at equal pay laws across the world, you will often see this exact phrase encoded into the language. But I'd like to interrogate what equal pay for equal work means. Okay. So suppose I have two workers, Bobby and Robin, right, who are working for the same firm. And I want to see if equal pay for equal work is satisfied. Well, I know what the first equal means, right? I can take the pay of Bobby and the pay of Robin and subtract the two, and either it's zero or it's not zero, right? That's straightforward. I'm less sure what the second equal means, right? So, are Bobby and Robin actually doing equal work? Well, it's possible that we say, with enough richness and what we mean by equal, no one's equal, right? So maybe we say Robin has a mustache and therefore he's not the same as Bobby, right? But beyond these kind of topological notions, we might have a more insidious response by firms, which is to say, okay, well, I'm going to slightly heterogenize the work that Bobby and Robin are doing so that no one can even claim they do equal work. Right? And in the US, when the first equal pay restrictions were put in place in the 60s, um, this so-called job title proliferation was fairly common. So Claudia Golden famously talks about this in her book. And if you were a subscriber to, let's say, the Washington Post in the 60s, you would see accounts of people saying, well, I'm a firm owner and I don't want to pay my women as much as my men. And therefore, all of my male secretaries are now promoted to executive assistant, right? And now they no longer do equal work. And the response in many localities has been to coarsen the second equal in the phrase equal pay for equal work to equal pay for similar or equal pay for comparable work, to get around the firms claiming that no workers are equal. So here is an example of such a law from New York State. So no employee of a particular group shall be paid a wage rate less than than another employee of a different group at the same establishment for similar work. So I'd like to do a couple of things on this slide here. So the first thing is I'd love to try to convince you that I'm not just picking up on different words used by different lawmakers and claiming that some big difference is happening, right? I actually wanted to convince you that these laws are different. And I also want to convince you that these laws are not rare, right? We should actually pay attention to the effects these might have on markets. And let me apologize in advance for my American centrism. So I was actually reading about equal pay laws in Europe last night, and turns out to be a bit of a mess. Much less clear the restrictions placed than in the U.S. But many of the same discussions that I'm going to have been had among the EU Charter and the laws across the different member states. So in the U.S., almost all of the states have some kind of equal pay law on the books. And up until maybe 15 years ago, I think all but one of them were of the form equal pay for equal work. But since then, in the last, as I said, a little more than a decade, many states have updated their laws to go from equal pay for equal work to equal pay for similar work. And now there are more U.S. workers covered under state equal pay for similar work laws than equal pay for equal work laws. And many states, when they're doing the transition, they explicitly say, look, equal pay for equal work was too restrictive. We want to make it so that the comparison is less restrictive, right? So California says this explicitly. New York says this. I was also in the Society of Labor Economics conference 2 days ago, which was in Oregon. And as it turns out, the highest judicial standard in the U.S. interpreting equal pay for similar work was from a professor at the University of Oregon suing for unfair pay. Okay, and so this I want to give you a sense of what we might mean in an actual application by what equal pay for similar work means. And the court ruled. So this is the Ninth Circuit Court of Appeals, and so this is one level below the U.S. Supreme Court, so this is the highest court that's ruled on anything like this in the U.S. And the ruling stated that the phrase there is comparable work. So comparable work is more inclusive than equal work, right? And it's not just that we're comparing two workers that are exactly the same, but they have to have important common characteristics, but not every characteristic has to be the same. And well, the person bringing the suit, Freyd, was a psychology professor. Maybe she still is. This was in 2016. I'm not sure. And the way they define comparable there is all of the faculty within a university department of the same rank. Okay, so all of the full professors in psychology in the University of Oregon are meant to be paid the exact same amount. Okay, all of the assistant professors in economics at University of Oregon are meant to be paid the exact same amount, and so on and so forth. Okay, so clearly, this law, the goal, right, is to make it such that workers who are clearly very different in productivity. I don't think we have any claim that two workers who are, or every pair of professors at the University of Oregon in psychology are exactly the same productivity, or maybe they're not even that close in productivity, but they're close enough such that they have to be paid the same amount. Okay, so let's talk about some intuitions about what a law like this might do. So suppose we have Robin and Bobby, who are employed by the same firm, and they're doing similar work. Okay, and suppose there is no restriction of equal pay for similar work. Well, and suppose Robin is paid more. Now, let's suppose we pass an equal pay for similar work law. Suppose we don't change Robin's pay, okay? And we also still employ Robin and Bobby. Then what does the law say? The law says Bobby's pay has to rise to match Robin's. And if we do this comparison between all pairs of workers, what do we see? We see the wages increase weekly for every worker. And the wage gap decreases to zero, at least within kind of these broad class of similar jobs. So that seems quite good, and we might think this is the intended effect of the policy. But there was a lot baked into this, right? What did I say? I said, well, this is assuming Robin's pay doesn't decline and also assuming that both of the workers are still employed by the firm. So the main inquiry is, in equilibrium, do we change employment patterns? And by changing employment patterns, do we also change wages and maybe wage gaps between groups? And let me ask a leading question here to kind of foreshadow what we might think will happen. Suppose a firm has 10 employees of a particular group, right? Let's say these are men, okay? And they're paid different amounts for various reasons, perhaps. Maybe they're differently productive, maybe some are better at bargaining, whatever. Um, and suppose there's one worker of the different group, so there's one woman, let's say, and the firm could either comply with the policy by paying everyone the same amount, right? So paying the woman the same as the highest man and all the men the same as the woman, which would mean the same wage for everyone. Or, is there another option for the firm? Could the firm just, happen to, no longer employ the one female worker? What if I replace this 10 men with 100 men or 1,000 men in one woman, right? So eventually, I think it seems quite compelling that the firm would rather change its employment patterns than to have to pay this constraint of equal wages. And so we're going to study this and develop these intuitions in this paper today. And primarily, I'm going to consider a very standard wage setting model between two competing and homogeneous firms. We're going to have workers that are heterogeneous in terms of their productivity, but they're all going to be deemed exogenously to be similar, right? So all these workers are fair game to be compared by the law. And to capture some institutional features, I'm going to focus on two groups of workers, okay, let's say men and women, and the equal pay for similar work, similar to the New York law that I described, that said you can't pay a man less than a woman and a woman less than a man. Okay. And I think the next two slides actually capture, kind of like 80% of the intuition for the talk. Okay, and the comparison I want to make is that the world without equal pay for similar work looks like Bertrand competition, and the world with equal pay for similar work looks more like Hotelling's location choice model. Okay, so here I've drawn this 0-1 line, which is meant to represent the boardwalk that Hotelling had where the firms can choose to locate their ice cream stands. Okay. And so without equal pay for similar work, we get a Bertrand-like outcome. It's as if the firms are kind of right on top of each other and they're competing very heavily for the workers. Okay, so we have a lot of competition. Now, if we're comparing the wages across workers, the workers might receive different pay because, well, they're potentially differently productive. And there might be differences in pay across groups because maybe there are differences in productivity, or maybe there's something, some kind of bias that's resulting in one firm being paid less. So I don't want to say that there's nothing wrong with a competitive outcome. There may well be. That's the purpose of the law, or at least the motivation for the law. With equal pay for similar work, we have something more like Hotelling's outcome, where the firms endogenously differentiate themselves as much as possible. The firms will segregate the workforce such that one firm hires all of the men and one firm hires all of the women. And in doing so, they gain local market power. Why? Because a firm that hires all the men finds it very costly to poach one of the women. Why? Because that would just, impose this equal wage constraint upon it. And same with the other firm. Okay. So we have this segregation. I think there's some reason to believe that segregation is actually bad among the workforce. Some recent literature talks about cost of segregation. But this is not directly speaking to the wage gap, wages across groups. And I think that's where the Hotelling intuition leaves us. What we find is that the wage gap is going to move in favor of the majority group. Okay? This has nothing to do with the productivities, the underlying productivities. So if there are more men than women, and there's a wage gap in favor of men before, that wage gap will widen. Okay, and if the wage gap is in favor of men, say, but there are more women, the wage gap will shrink, or possibly reverse. Now, there's a question, Arda?
Yeah, so I'm just wondering, so one of your initial slides, you started by saying that, okay, so we should worry about the firm's sort of ability to set wages.
Mm-hmm.
And based on what you describe here, it seems more like, there is two firms that are in perfect competition of some sort. And I'm wondering if there is a way to sort of turn on off some sort of and some aspect of that competition, or
I see. So yeah, so I think that's a great point, and let me let me say a few words. So the first thing I do want to say is that the model we'll have is going to be extremely frictionless. Okay? Um, we um, we have many extensions in the paper to insert heterogeneity between the firms, and that creates kind of some more wage setting power. We're also kind of working on a model where there are explicit search frictions and reallocation frictions, and these things can lead to kind of different wages and maybe even kind of heterogeneous wages for workers who look exactly the same, depending on, let's say, who had more offers or something like that. Um, the intuitions hold in these settings. And so what I'm going to tell you today is going to be, I think, the cleanest way I can make the point. But I don't think that our results hinge on the cleanness. But thank you for that. Yeah. Okay, so here are the findings, and the first two bullets basically say what I just said on the last two slides. Um, One other thing I want to point out is we have an empirical exercise in this paper as well. I'm not planning to spend too much time on it today, but I will give you a flavor of what that looks like and show you some plots. We have an event study analysis of an equal pay for similar work law that was enacted in Chile in 2009. Okay. This equal pay law kind of institutionally will look exactly like the model I present. And we find exactly what the same findings as I shouldn't say exactly. We find what we think are kind of validations of our main theoretical results. So we see an increase in the share of the firms that are gender segregated following the passage of this law, and the firms that are treated. Right? And we see an increase in the wage gap, increase meaning in favor of men, in male-dominated industries. But actually, we see the opposite in female-dominated industries. And by dominant, I just mean the majority group. Okay, so again, it seems like the majority group is relatively benefited by this law. So if there are no other questions now, I'm happy to jump into the model. Also happy to take questions. Okay. Okay, so uh, to Arta's point, we're going to have a very simple and frictionless model today. So we're going to have two homogeneous firms that exist in the labor market. And we're going to have a continuum mass of workers, all of whom are exogenously deemed to be similar. Okay, so we can think of these as assistant professors of economics. Right? Now, again, we should think of the comparisons I'm going to give you as kind of being quote unquote within job, right? So we could have a market of assistant professors of economics and a different market for associate professors of economics, and maybe a different market for assistant professors of psychology, and so on and so forth. Right? So we're just going to investigate each market in isolation. Each worker has a type, VG, where V is the worker's quote unquote productivity. I'll come back to that in a second, but productivity is going to be a number between 0 and 1. And G is the group identity. There are two groups, A and B. In the empirical setting, this will be men and women. There will be measure 1 of B group workers and measure alpha of A group workers, where alpha is weakly larger than beta. Without loss of generality, one group has to be weakly larger than the other. We'll take that to be group A, and alpha will be um, the how many more men there are than women. The productivities, the distribution over V's, will be given by FA and FB. These will have full support over 0, 1. They'll have everything will be continuously differentiable, and the densities will be bounded. So these are, I think, somewhat standard assumptions. I won't need many of these for some of the results I tell you today, and the continuity and then the differentiability is useful for some things that we'll use calculus for, which I may not get to today. Types are going to be commonly known, so there's nothing interesting informationally going on. Okay, so two things I want to point out about this slide. So I keep putting productivity in quotation marks. That's number one. And number two is I haven't said much about the distributions about productivity, just that they satisfy some technical conditions. Okay. So, what is this flexibility bias? Here I've drawn the PDF for Group A, FA. This is an example PDF. Well, it could be that when I say productivity, maybe I mean worker output, right? So this is the number of widgets made per hour or something like that by the A group. Could be that the B group has the exact same output, or the distributions are exactly the same. So the two groups are equally outputty, right? It could be that the two groups are equally outputty, but that there's discrimination against the B group. Okay. And what I'll call productivity in that world means kind of output net of discrimination, right? So it could be that we have, in this picture, maybe case-based discrimination that reduces the output of the productivity of every B group worker by some amount. Okay, so that's allowed, and we can think of productivity maybe as being net of discrimination. It could also be just that the groups have completely different distributions for whatever reasons. Okay, I'm going to be completely agnostic about what the distributions look like. And I'm very open to various interpretations of what productivity means. I'm just going to, in the model, this is just going to be what the firm would be willing to pay a worker in isolation. All right, so I'm going to describe a wage setting game. And an outcome of this game is going to specify who goes where and what they're paid. Okay, so this FIGV is going to describe the density of workers of type VG who are hired by firm I. Okay, and this has to satisfy an adding up constraint. So we can't have more workers of type VG that are hired by the two firms than actually exist in the market. The second is who's paid what. Okay, so WIGV is going to be the wage that firm I pays to the workers of type VG that it hires. We are going to require that wages paid to workers be non-decreasing in productivity type within group and firm. Okay, so formally what I mean is, if there's a firm I that hires workers of productivity V of group G and V prime of group G, where V is bigger than V prime, then the pay WIGV has to be weakly bigger than WIGV prime. Very good. And this is based on, we think of this as kind of a reasonable mechanism design constraint, an incentive constraint. Following Sonmez 2013, looking at military cadets and their incentives to kind of do well on tests. And the idea is, well, if I would be paid more for being worse at my job, then I would be worse at my job. Okay, so we're thinking of a world where it's actually quite hard for workers to increase productivity. Let's say I can't pretend to speak French, but I could pretend not to speak French, right? If that was a useful component of the job, if it got me paid. Okay, this is, I think, the most notation heavy slide, so hopefully this is clear. And the payoff from a particular outcome, the firm is going to have a constant returns to scale production function. So let me jump to the second integral here. What it's saying is the firm gets the productivity minus the wage for each worker, and it hires this fraction of them. And then we integrate up from 0 to 1. And this is for the B group. Same thing for the A group, but we have this multiplicative factor of alpha in front because there are just more A group workers. So this is the firm's profit. A worker's profit is just the wage they receive, and they receive a wage of 0 if they're not hired. The way this game will look is we will have firms simultaneously making wage offers to subset of workers. So the firms select which workers that it makes offers to, and it also picks the wage it pays to VG types if it makes offers to them. Each worker is going to privately collect the offers. So there's either none or one from firm one, one from firm two, or maybe just one from one of the firms, and selects at most one. And we'll look for a pure strategy subgame perfect Nash equilibrium of this game. Okay, so a bit of an aside. So just like Bertrand's game, where firms set the same wage and the workers the consumer buys from one firm. The purpose of the other firm is kind of a shill bidder to discipline the firm that actually sells the product to the consumer. Our equilibrium will also involve shill bidding. Okay. And so once we know what one firm is paying, we know what the other firm is paying. Additionally, in the paper, we show that the set of subgame perfect Nash equilibria outcomes of this game that I've described is equivalent to the set of core allocations in the same model, but a cooperative solution concept, okay, where we don't have these notions of timing and strategies. And because of these 2 points, because of this equivalence, and because the outcome is going to pin down the strategies, I'm going to focus only on describing the outcomes. Okay, and I won't tell you the strategies that the firms make, but I think that should that still should be clear. Okay, so now we're ready to jump into the equilibrium outcomes. If we don't have an equal pay for similar work, as I promised, we have something that looks a lot like Bertrand's outcome. Okay? In equilibrium, almost every worker is hired by one of the firms, we don't know which, we have a multiplicity, and receives a wage equal to her productivity. Now I've included almost in parentheses here because we have a continuum of workers, and we're always going to have this multiplicity due to outcomes that are similar, but for zero measure sets of workers. Okay, so I'm quickly going to ignore these and drop the almost. But I just wanted to make that clear here for the first reason. And so to draw a picture, I've drawn on the horizontal axis the worker productivity, and on the vertical axis the worker's wage. And the dotted line is a 45-degree line. And what this says is if we take a worker whose productivity is VE, their wage is going to be exactly VE. That's what we just said in the previous result. And so if we want to plot the wages, it's going to be exactly this 45-degree. Now we don't know where the workers are going, but regardless of where they're going, they're receiving their full productivity and wage. And the intuition for this, I'm going to give you the intuition just from a Bertrand sense as well. Suppose not, then there are some workers who are paid less than their productivity, and the other firm could jump in and pay just 1 cent more and hire that worker. Now this doesn't actually hold directly in our model because we have this wage monotonicity constraint. So if you raise the wage, kind of one worker, it's not just that you can locally do this, but you might also have to increase the wage of the workers kind of who are more productive in order not to violate the monotonicity constraint. We actually found this quite challenging, and maybe because of that, we find it potentially interesting. So I don't know if this is something of independent interest or not, but it seems like this Bertrand intuition holds even in the face of additional kind of incentive constraints. So I won't go through the proof. It's a proof by masochism, unfortunately, just many ugly cases. Okay, so what does this mean? Well, if every worker gets their wage and productivity, we also have a very, very simple calculation for the average pay of workers in a particular group. Okay? And what is that? Well, pay is equal to productivity. So the average pay is just equal to the average productivity of that group. And I'll represent this by this EGV. And going back to the second slide of my talk, if we're comparing differences in the average wages, we will call the wage gap EAV minus EBV. Okay, this is the average A group wage minus the average B group wage. Again, I've said very little about the productivity distributions. This number can be positive, right? It can be negative. It can be zero. And it won't matter for the results what the sign of this term is. And I gave you an example where, maybe the workers have the exact same output, but there's case-based discrimination of value, let's say B against the B group workers, little b against the B group workers, and that such that it shifts the distribution down by an additive factor of B. What would that mean? That would mean that the wage gap is exactly this little b. Good. Okay, so that was the kind of straightforward case without equal pay for similar work. Now suppose we do have equal pay for similar work. And just to remind ourselves, this is taken from the New York law again. It specifies that pay across groups has to be the same, but there are no restrictions on pay within groups. Okay? And interpreting this in the lens of our model, if a particular firm hires A group workers, okay, and B group workers, then it can't pay any A group member less than the highest paid B group member, and no B group member less than the highest A group member. And so what does this mean by transitivity? All workers have to be paid the same amount if both groups are hired. On the other hand, if the firm hires workers of only one group, then equal pay has no bite. So here are two kind of preliminary results with equal pay for similar work. The first is that there exists a continuum of equilibrium outcomes. And the second is that we have segregation in all of them generically. Okay? And what that means is one firm will hire all of the A group workers and one firm will hire all of the B group workers. And let me sketch the proof of existence first, and then I'll talk about the proof of segregation briefly. So let me construct a continuum of equilibria for you. These are going to be equilibria that have segregation because I've already told you that they all have to have this, but we haven't shown that yet. I'm just going to construct this. Okay. So the first restriction that we have to satisfy in any equilibrium outcome is equal profit. The two firms have to make the exact same profit. And why is this? Well, if not, one of them is making less than the other. Suppose that's firm one. Well, firm one could deviate to just not hiring any of the workers it was originally supposed to hire under equilibrium strategies, hiring all the workers that the other firm is paying by just paying, a fraction of a cent more. That would lead to higher profits. Okay, so we know we have this equal profit condition. And so let me construct equilibria for you now. Let's look at equilibria where firm one, and we're hypothesizing that this exists, that firm one hires all the A group workers and firm two hires all of the B group workers. And so here's our picture again. And here's a particular wage schedule that we're going to have firm one pay. Okay. Firm one is going to pay wage equal to the productivity, but it's going to be capped at some number delta, where delta is something close to 1. So it's going to look like this. All the workers who are of productivity less than delta receive their full value, their full productivity. All the workers above delta receive delta. Let's do something similar for firm 2. Okay. Firm 2 pays 0 to all the workers who are less than some delta prime, and the full productivity to all workers who are above delta prime. Okay, so this is, again, firm 2 is hiring B group workers, and firm 1 is hiring all the A group workers. Now, delta prime is some number close to 0, and delta prime is picked such that the two firms make equal profits, right? So the kind of this triangle here is the same as this triangle here, where we're kind of appropriately weighting by the densities of the workers. Okay, so I claim this is an equilibrium. Are there deviations? Well, the firms are, again, the firms are making the same profit, so there isn't a deviation where one firm just, fires all of its own workers and poaches all of the workers of the other firm, because that would That would not result in higher profits. So the only way to make higher profits is to deviate to hiring workers of both groups. But if you hire workers from both groups, you have to pay a common wage. Let's call this W. Suppose firm 2 paid a common wage W prime less than delta, right? So there's some common wage that is less than this value delta. Well, right, it's not able to poach any of the A group workers because all the A group workers are either paid more than delta or they're paid exactly their productivity, in which case there's no profit to be made by. Okay. So firm 2 can't poach any new workers and potentially loses some workers, so the profits are lower. And if it were to set a deviating wage of more than delta, okay, well, it doesn't make any profits from B group workers because there's no profit to be made from B group workers at the top. It would poach some A group workers, but it would do strictly worse than firm 1 is doing already, right? Because it's paying a higher wage and poaching fewer workers. Because the profits are equal, what does this mean? If the deviation nets firm 2 less than firm 1 is making under equilibrium strategies, which is the same as what firm 2 is making under the equilibrium strategies, then this is not a profitable deviation. And you can see that the picture is somewhat symmetric, and so if we were to do a similar argument for firm 1, we'd get a similar result. Okay, so there's no deviation whereby a firm can make higher profit. And notice that I've picked delta and delta prime somewhat arbitrarily, right? So as long as these things are close enough to, as long as delta is close enough to 1, we'll have a delta prime close enough to 0 by our full support assumption, and we can vary the exact amounts of delta and delta prime to get many different outcomes, many different equilibrium outcomes. Now, it's not that every equilibrium outcome has to have this structure. In fact, we know that, but at least we can construct many equilibria of this form. Okay, so we have many equilibria. We also have segregation, and I won't go through the proof of that in as much detail, but we should think of the proof as kind of a discretized version of Hotelling's proof, where we consider various cases, right? So we consider the case where both firms hire from both groups. We can think of this as like both firms kind of locating somewhere in the middle on Bertrand's line. And we find that this doesn't work because one of the firms will have an incentive to specialize in one of the groups. We can't have both of the firms specializing, let's say, in hiring from group A only, right? So that's too much competition in one niche market because one of the firms could deviate to hiring all of the B group workers for free. And we can't have both of the firms, we can't have one of the firms kind of being a generalist in hiring from both groups and the other firm being a specialist in hiring from one group, because the firm that hires from just one group can outcompete the other firm because it doesn't have this equal pay constraint. Yeah. And so the segregation will hold in equilibrium. So fine. So let's say we're happy with where we are now. We have many equilibria. We have segregation. I think we probably don't like segregation for various reasons, but that's not explicitly what the law is meant to target. And I haven't said anything about wage gaps. And from here on out, the Hotelling intuition, we're going to lose it, and I'm going to tell you what happens to the wage gap, and it's going to be based only on multiplication, basically. Here is what we think of as the main result. Equal pay for similar work increases the wage gap if alpha is bigger than 1. Remember, alpha is the fraction of the A group workers, so if there are more A group than B group workers, the wage gap will increase. Again, there's nothing special about A group here, so if the B group worker was, there were more B group workers than A group workers, same thing would happen in reverse. Very good. So, so let me prove this result for you. And before I do that, let me give you a characterization lemma for an equilibrium outcome. Let's consider an outcome in which firm one hires the A group workers and firm two hires all the B group workers. Recall that without loss of generality, we have that this occurs in any equilibrium outcome where I've just assigned one to group A and two to the group B. And equilibrium, a particular outcome is an equilibrium outcome if and only if the following three conditions are satisfied. The first is an individual rationality constraint. No worker is paid more than her productivity. This is straightforward because the firm would be better off just firing this worker. Or rather not hiring them in the first place. The second is that the two firms have to have equal profit. We already described this on one of the previous slides. And the third is, we think, a novel condition that looks like an IC constraint on the firms, which we call a no desegregation constraint. So let me describe this this notation first, and then I'll show you what this means in a picture. So let this Wi inverse of epsilon be a sort of generalized inverse function. Okay? Why generalized? Because as we see, we the wages can have flat regions or discontinuities and things like that. So we need to account for these kind of nuisances. And it's the highest productivity worker who is paid no more than this value epsilon. And what this no desegregation constraint says is that for all values of epsilon between 0 and 1, this inequality has to be satisfied. Firm two's profit has to be bigger than the sum of these two integrals. Okay, so let me show you in pictures what all these means, and then I'll come back and convince you that the pictures kind of have some intuition for what this kind of ugly integral is. So suppose I have these two wage schedules, and I want to see if these are an equilibrium outcome. Okay, so the red one is the wage that firm one is paying to the A group workers, and the blue one is what firm two is paying to the B group workers. First thing is that it's very easy to see that the incentive, the individual rationality condition of the firms is satisfied, and that's because both of the curves are pointwise below the 45-degree line. No one is making more than what they're bringing into the firm. The equal profit condition says this shaded blue area, right, which is, what is it? It's just the productivity minus the wage paid times all of the density of all of the B group workers, because firm two is hiring all the B group workers, integrated up, right, which just looks like the average quality of the B group workers minus the average wage paid to the B group workers. So this weighted blue area is the same as the weighted red area, where the only difference is we have this alpha term here because there are alpha measure of A group workers. So we need the red area and the weighted red area and the blue area to be the same size. What does the equal profit constraint say? Sorry, the no desegregation constraint. It says, for every value of epsilon between 0 and 1, I've picked epsilon to be this value for demonstration purposes. The profit of firm 2, which we saw was this shaded blue area, has to be bigger than two triangles. The first is this red triangle. Suppose firm 2 set a common wage of epsilon. It would be willing to hire all the workers whose productivities are at least epsilon. All the workers below that are not worth it. And it's able to hire from the A group all the workers who are paid less than epsilon by firm 1. Okay? And from these workers that it hires, okay, it makes this red triangle of profit because it pays all of them epsilon. From the B group, it gets this triangle. Same thing, but using the blue wage schedule instead of the red. Okay? It's willing to hire all the workers who are at least productivity epsilon and who are paid no more than epsilon. So the sum of these two areas has to be less than the sum of the area it was getting from just the B group workers here. And if we go back to this, that's exactly what this is saying. Okay, This is the first blue area, and then these are the two triangles I'm given. So this is we're poaching all the workers who are at least worth epsilon and who are paid no more than epsilon, because the ones who are paid more than epsilon are not poachable. This has to be satisfied for every value of epsilon between 0. Very good. Now returning to the proof of the wage gap result, I'm just taking the terms that we had in the pictures before. The equal profit condition tells us that pi 1 equals pi 2. What is pi 2? It's just the average quality of the B group minus the average wage of the B group. And that equals the same thing from the A group multiplied by this alpha, because there are more, again, more A group than B group workers. By individual rationality, we know that this is a weakly positive number. Why? Because no worker is paid more than their productivity, so the average wage can't be more than the average productivity. And if alpha is bigger than 1, just rearranging this, we have that this inequality arises. What is this? Well, this is just the wage gap under the equal pay for similar work law. This is the wage gap without the equal pay for similar work law. Remember, it's equal to the difference in the productivities between the groups on average. And there we go. Higher wage gap under equal pay for similar work. Indeed, this inequality is strict unless the two firms make 0 profits. There's only one equilibrium in which the firms make 0 profits, and that's exactly the Bertrand outcome replicated again, where everyone is paid equal to their productivity. So there are a continuum of equilibrium outcomes. That's just one of them. Now, if we're worried that about which equilibrium selected, of course, I don't know. But what this says also is that the larger the wage gap, the larger the firm profit. So that to the extent that the firms have an incentive to or are able to select an equilibrium, they're going to select one with maximal wage inequality, because that will maximize their profits. So that's the kind of result, as we call it in the short run. And by short run, I mean I'm holding fixed the set of workers that are available in the market. Now, there is this sense, I think, this popular opinion that maybe in the long run things will get better. And so here's what the Obama administration said about 10 years ago, celebrating the 50th anniversary of the Equal Pay Act of 1963, which was an equal pay for equal work law, not equal pay for similar work law. But what they're claiming is, look, this law was great, and it allowed women to join labor markets where they were previously extremely underrepresented. Okay, so there was a sense in which over time we actually kind of increased the diversity of workers in different industries. And our model casts doubt on making a similar claim with equal pay for similar work. Very roughly, what we show is that when there's a higher share of the majority group, which means alpha is bigger, okay, we can support larger wage gaps in equilibrium. And so we'll have a bigger and bigger difference in the average pay between the A group and the B group. And if we think of a model where workers kind of over time choose which industry to join based on the wages they can expect to receive, then what this says is that having this equal pay for similar work law might lead to something known as occupational tipping, where if we have too few minority workers to begin with, the wages are going to be super low, and then the next generation is just going to the minority workers are going to completely choose away from that workforce, where we have even more kind of even more dominance by the majority group, which kind of leads to the cycle whereby we have segregation across occupations as well. And I don't have time to go through this result, but we build additional machinery to show this. So I'm running very short on time. So let me just say a few words about empirical results we have. Okay, and we're going to test I guess what I call the main predictions is that group-based equal pay for similar work leads to a higher segregation across firms. And also that the wage gap increases in favor of the majority group in a labor market. So we look at Chile, which enacted an equal pay for similar work law in 2009 and punished firms that were in violation. Um, what was very nice for us in terms of identification was that there were basically no other laws about equal pay or anything related really on the books in Chile in 2009. Actually, I believe that this equal pay for similar work law was the first equal pay law in all of Spanish-speaking Latin America. So that's anyway. The law specifies two groups of workers, men and women. So that's kind of the model I gave you already, and only affects firms above a particular size threshold. And so this allows for us to do a pretty straightforward difference in difference analysis, where we're looking before and after the policy, and the quote unquote treatment firms that are affected by the policy just above this threshold, and the control firms that are just below this threshold that are not affected by the policy. And we test the following predictions using matched worker firm data. And here's what we find. We find that there's a rise in the share of gender segregated firms. Okay, so what I call gender segregated means firms that have workers of only one gender. At baseline, there were about a third of firms, a little bit less, that were fully segregated. And the segregation increases by about 3 percentage points, so 10% off the baseline. Now we might think that there's just a move towards kind of like more segregation, but really what what we're predicting is that this policy is going to create this kind of knife edge case where 99% segregation is not good enough, 100% segregation is what you need. Okay. And to avoid the kind of like a bite of the law. And what we find is that there is approximately the same decrease, so about 3 percentage points, in the share of firms that are not quite fully segregated, but almost fully segregated, right? So we should think of these as high amounts of the majority group is like 80, 85, 90, 95% of the workforce. We find a similar drop in these. So there's a missing mass of these, and our interpretation is if you were a firm that found yourself with, one or two workers of the wrong gender, right, in the minority group, you find a way to lose these workers after the policy. About the wage gap, we find that the gender wage gap rises. Okay, so there's a wage gap in favor of men before the policy, and this increases in the post-policy. This is not that surprising because the majority of the workforce in Chile is male. Labor force participation is relatively low. But we can actually, kind of zoom in on our predictions a bit more by looking at various local labor markets defined by industry and geographical region. In the male majority labor markets, this goes up, right? So there's an increase in the wage gap. In the female majority labor markets, this goes down. So exactly our prediction that the majority group is relatively benefited holds here. So I don't have time to go through these specifications. There's nothing there's nothing non-standard about these, I don't think. But let me just show you these pictures. So here's the segregation. We should think of each of these dots as being the change in the segregation relative to the baseline period right before the law. We see that segregation increases in the treatment firms relative to the control firms after the law. These are the fully segregated firms. Looking at the almost segregated firms, we see the opposite impact, and then we see this decrease in them. in terms of the wage gap, here's the kind of raw wage gap. When we zoom in on male majority industries, we see that the wage gap kind of goes up even more. In the female majority industries, it falls. So exactly what I wasn't just lying on the previous slides. We actually have some plots to back this up. Okay, so let me go ahead and conclude. And I've been quite pessimistic, I think, and I've kind of painted a bleak picture about the role of equal pay for similar work. Okay. So both theoretically and empirically, I've tried to demonstrate that equal pay for similar work can backfire, right, in terms of increasing segregation and the gender wage gap, at least in male majority industries. And in the long run, I mentioned that this can get even worse. And so the question is, should we just give up on equal pay for similar work altogether and just say, look, it's a bad idea? And I think of this as kind of being a market design. So maybe this is relevant to or especially relevant to the topic of the seminar series. And maybe not. Maybe we shouldn't give up on this altogether. And the reason is that, a key force that's present in our model that's driving a lot of the results is really what, the distinction between Hotelling and Bertrand's model, which is given the ability of the firms to differentiate themselves, they will do that to avoid lots of competition with the other firm. But what if we restrict the ability of the firm to really do this? And in our context, what does this mean? What if we remove incentives to segregate by group? We might think there are a number of ways to kind of break segregation and equilibrium. So one is that we have an equal pay for similar work law that doesn't have these protected classes. So it just says any two workers who are similar in their kind of, who are deemed to be similar have to pay the same amount. None of this men and women or group G and group G prime. We could impose hiring quotas on the different groups to prevent full segregation. Alternatively, we could just proliferate the number of protected classes. Okay. What's actually important here is the number of protected classes versus the number of firms. But let me give you a flavor of this. So the New York law that I gave you before, it said you can't pay a worker of group G more than a worker of group G prime, or vice versa. A worker's type is defined along 11 different characteristics there. Okay? And it's the intersection of these that define a particular worker. So a gay black male veteran is a different group than a gay black male non-veteran. And so if there are 11 groups, even if each of these groups is just binary, there are more than 2,000 different groups. At some point, if there are too many groups, it doesn't make sense to specialize in just one because that's too small a fraction of the labor market. Okay? So if you proliferate the number, you essentially destroy the incentives of the firms to segregate by group. So if we kind of do one of these things to break the kind of group-based nature of equal pay for similar work, we'll have an equilibrium structure that looks like this. So I've kept it to two firms here. So one firm will hire, we won't have segregation by group, but we'll have segregation by productivity. So one firm will hire the top productivity workers in the market, pay a common wage to all of them. Another firm will hire kind of lower productivity workers and pay a common wage to all of them. Now, we might have unemployment at the bottom, but we have no wage inequality within group, large wage inequality across groups. I've just said all of this in the picture, but here it is in words. The good news is that this can actually close the gender wage gap relative to equal pay for similar work. It's not guaranteed to. We actually can show that there are markets where the wage gap in some equilibrium can rise, in some equilibrium it can shrink. But at least there's hope for a policy like this to actually close the wage gap. And so perhaps changing the policies to be more in line with what New York has done would actually be beneficial. Okay, so thank you so much. and it was a real pleasure for me to be here. I'm happy to stay and take questions if there are any. And if there are questions or comments that come up, I'd be very happy to speak offline as well. Thank you again.
Thank you very much
Thank you.
for this inspiring talk and for bringing up new views on pay regulation. If you have any questions, just raise your hands. I see there's already a hand.
Yes, I see a question by Arda.
Yeah, Bobby, so thank you very much. So amazing, sort of very clear
Thank you.
presentation. I was just wondering, so I mean, at some level, like this, I guess, like the reason why sort of states employ these type of policies is because, like, I mean, some group, which tends to be, I guess, group A in your setting, is more likely to get a wage that's closer to their productivity to begin with. They have like higher bargaining power, whatever, etc.
Okay.
And I was wondering, like, maybe like wondering about the following variant of the model. Like, I mean, Group A has a distribution of outside options that depends on their individual productivity, and maybe your outside option increases with your productivity, so that you have to make a wage offer that's beyond a certain level. So do you know how sensitive your results are to those type of sort of
Yeah,
extensions?
I think that's a great question. So all of the machinery will go through if we place a kind of like minimum wage restriction that differs by productivity. We might think it's increasing in productivity to represent the outside option. So here, the outside option for all the workers is 0. Now, if it were the case that the majority group had a lower outside option than the minority group, that would actually let me say this. Actually, that wouldn't change anything. What would happen is the higher the outside options of the minority group, the smaller the wage gaps that can arise. So it just places a bound on that. So to the extent that we think that the minority group already has lower outside options, then and maybe they're quite low, then our results would kind of hold as is. And the results I didn't talk about, we actually show conditions under which the B group workers can all get pay exactly equal to 0. Now, obviously, that won't be true if they're outside options, but we could say, here's a condition under which all the workers receive exactly their outside option. And that will be that the alpha, the imbalance in the market is large already. So that was the long answer. The short answer is if we impose outside options, nothing changes qualitatively, but it just restricts the quantitative gaps that we can get. Thank you. Yes, Elena.
Yeah, my question would be regarding quotas. So would the result change continuously in the amount of the quota, or would even a small quota potentially distort the whole equilibrium?
Yes. So if we have a quota that says a firm is fined $1 million, right? So there's some constraint that says you have to have at least X% of your workforce be of each group. That would discontinuously change. So any quota would break the result and take us to an equilibrium that looks like this, a structure that looks like this. So yeah, so this I think this is quite a well-known paper looking at I think in board members in Denmark, and I think the restriction was you have to have at least 40% of the board members be women. No, I don't have much to say about that, but what I mean is we don't need such a huge quota in our setting.
Okay, thank you.
Thank you. Charles?
Hi. So I'm thinking about if you use some characteristic that is not observable, let's say veteran status, which is not observable if you present your evidence. So this kind of not observable characteristic and make it as 2 groups, is that going to help the equal pay for similar work?
That's a great question. So here, here the types were observable, and actually quite important in the way that the firms set the wages, because, well, as I described, I guess. So if we think that types are not observable, I guess I think this model would say, because there are many workers, right? If there's some, if you get a signal of the worker's type, of the worker's group, but you're not 100% sure, then I think that would also break the segregation in the same way that the quota would, and it would be discontinuous because it's saying, look, you have infinitely many workers. You're going to make a mistake every once in a while with your signal. Your signal is going to be wrong, and so no matter what you do, you're going to hire some workers of different groups, and once you do that, that's going to happen. You have to pay a common wage. So maybe I should amend what this says here is that if there are many protected classes, or you kind of can't observe the protected class exactly, that will also break the segregation result, and we'll get an equilibrium outcome like this.